In this video on exponents, we're going to have a look at simplifying fractions with multiplication and division. It is very important that you know your exponential laws and that you realize that they can be used in both directions. Sometimes, for example, you might have 2 to the power of x times 2 to the power of y, which you can then rewrite as 2 to the power of x plus y. Or for your specific question, it might be that you receive the right-hand side and should expand to the left by giving each term in the exponent its own base to be able to simplify. I'm reminding you that you are allowed to rewrite your base numbers. For example, you might have 8 to the power of x and want to rewrite 8 as 2 to the power of 3. You can, however, not simplify base numbers when using the exponential laws. So you might have 2 to the power of x times 3 to the power of y, and then you cannot say that it is 6 to the power of x plus y, because you cannot change the base numbers when using your exponential laws. Similarly, when dividing, you cannot, in this case, say 16 divided by 4 is 4 to the power of x minus y, because these first three laws can only be used if the base numbers are the same, and law 4 and 5 can only be used if the exponents are the same. Let's go and have a look at some examples. In the first example, we have only constant values and no variables. We also have exponents, which means I cannot simplify by dividing the two 2's. Because I have exponents, I would like to use my exponential laws. However, I need to realize that 16 can first be rewritten. If I rewrite 16 in terms of its prime factors, it will be 2 to the power of 4. The reason for rewriting in terms of prime factors is that when all the bases are prime numbers, the chances of some of them being the same and you being able to use your exponential laws are bigger. Now, all my bases are 2's and I can use my exponential law. I'm going to start off multiplying at the top in my numerator, and the law says that the base will stay the same. And when multiplying, I add the exponents, and here we have 3 plus 4, which will give me 7. Next, I'm going to divide, and I will divide by keeping the base the same and subtracting the two exponents. So that will be 7 minus 6, and my final answer is 2. In example 2, we now have variables in our exponents, but the steps stay the same. I want to get all the bases the same, and to do that, I will write them in terms of prime factors. So 4 I can rewrite as 2 to the power of 2. Next, I'm going to use the third exponential law, and that law says that when I have one base with two exponents, I will multiply those exponents. So here I will have 2 to the power of 3x times 2 to the power of 2x. And now I have two of the same bases that are multiplied. So my first law says that then the base will stay the same, and I add the two exponents, which will give me 5x. In example 3, we now also divide. Still, I would like all the base numbers to be written in terms of prime factors. 2 is already a prime number, but 8 can be rewritten as 2 to the power of 3. 32 can also be rewritten, and this will be 2 to the power of 5. Next, I'm going to get rid of the brackets by using the exponential law and multiplying those exponents. So 3 times x is 3x, and in the denominator 5 times x is 5x. Now you can simplify all at once, or you can choose to first simplify the numerator by adding up the exponents, which will be x plus 3x is 4x. This should now be divided by 2 to the power of 5x. When I divide, the base still stays a 2, and I will have 4x minus 5x, which will give me minus 1x. In example 4, I will again start by changing all the base numbers to prime factors. 5 is already a prime number, and I'm just reminding myself that the exponent is 1. 45 can be rewritten as 3 squared times 5, and the whole 45 is to the power of x. And next we have 9, which can be written as 3 squared to the power of x, and 5 is already a prime number. Next, I'm going to get rid of the brackets, and in my numerator, I'm going to use 2 laws to get rid of the brackets. Firstly, the x needs to be applied to both the base numbers, and for 3, I will then multiply the exponents to get 2x, and the same for 5, it will be 1 times x. In the denominator, I will have an exponent of 2 times x. And now that the base numbers are all prime numbers, some of them are the same, and I can therefore use my laws. I'm now going to use my exponential laws to combine all the 5 base numbers, and then also combine the base numbers of 3. If I focus on the base of 3, you will see that in both the numerator and denominator we have exactly the same exponent. And anything divided by itself is 1. For the base number of 5, I'm first going to simplify the numerator, and when multiplying the same bases, we add our exponents. When I now divide these two same bases, the law says the base stays the same, and I take the top exponent of 1 plus x, and I subtract the bottom exponent of x minus 2. Now I can simplify that exponent by multiplying in the minus, and once that is done and I simplify the exponent again, I will end with 3 because x minus x is 0. 5 to the power of 3 is 125.